Hello everyone. Today we are going to study Zener diode. First of all, we'll see what is Zener diode. Zener diode is a semiconductor device that follows current to flow in either a forward or reverse direction. The diode consists of a special heavily doped PN junction designed to conduct in the reverse direction when a certain definite voltage is reached. Here, the symbol for Zener diode is shown. We can draw a symbol like this also. Here we have a triangle and a straight line with a small tilt, or we can have such kind of symbol also where a triangle is there and a straight line with little bit split on both the sides. Even we can draw simply S in place of this line. So this is the cathode, this is the anode, and this is all about the symbol of Zener diode. This Zener diode has a well-defined reverse breakdown voltage at which it starts conducting current and can operate continuously in the reverse bias mode without getting damaged. The voltage drop across the Zener diode remains constant over a wide range of voltages, due to which Zener diode is very much suitable for voltage regulation. Let us see the working of Zener diode. Here we can observe this Zener diode is connected in a reverse bias. Here is the output waveform when it is connected in a reverse bias. The Zener diode operates just like the normal diode when it is connected in forward bias mode, and it has a turn on voltage of between 0.3 volt and 0.7 volt. Let us see the characteristics of Zener diode. When this Zener diode is connected in a reverse bias mode, a small leakage current may flow through this. As the reverse voltage increases to the fixed breakdown voltage, a current starts flowing through this diode. This Zener breakdown effect occurs below 5.5 volt. It is not more than 5.5 volt. This point. The current increases to a maximum, after which it stabilizes and remains constant over a wide range of applied voltage. So these are the characteristics of Zener diode. This Zener diode is also worked as a voltage regulator. Now first of all, we'll see what is the function of a regulator. This regulator provides a constant output voltage to the load connected in a parallel with it. The Zener diode will continue to regulate the voltage until the diode current falls below the Zener current, minimum Zener current, in the reverse breakdown region. It flows current in the forward direction as normal, but will also allow it to flow in the reverse direction when the voltage is above a certain value. And that value we have seen in the earlier, that is less than 5.5 volt. Now we'll see the working of the Zener diode as a voltage regulator. Here you can observe what we had done. We have this Zener diode, load resistance. This is the resistance in series, and this is the combination, or we can say this is the shunt resistance also we can say. Here, first of all, we'll see how this circuit is obtained. The resistor is selected so that when the input voltage is at minimum and the load current is at maximum, that the current through the Zener diode is at least Iz minimum. Okay. Then for all other combinations of input voltage and this load current, the Zener diode conducts the excess current and maintain a constant voltage across this load. The Zener diode conducts at least current when the load current through this RL, that is the load current, is highest, and it conducts the most current when the load current is lowest. If this load current is lowest, means Zener will conduct high. This load current is highest, means Zener will conduct lowest. If there is no load resistance, if this load resistance is removed, what will happen? Shunt regulator can be used to dissipate total power through the series resistance and the Zener diode. Shunt regulators have an inherent current limiting advantage under the load fault condition because the series resistance limits excess current. Now, this Zener diode, the breakdown voltage Vz is reverse connected to an input voltage source Vi across the load resistance and a series resistance. The voltage across Zener will remain steady at its breakdown voltage Vz. For all the values of Zener current Iz, the current remains in the breakdown region. Hence, a regulated DC output voltage, which is VO is equal to Vz, is obtained across this RL whenever the input voltage remains within a minimum and maximum voltage. Okay. We have seen the rectifiers, and this Zener diode regulates the voltage from the rectifiers. The current coming from the rectifiers, that is regulated by this circuit, which we call Zener diode as a voltage regulator. Okay. This regulation is of two types. One is line regulation and another is load regulation. So let us see line regulation. In this type of regulation, series resistance and load resistance are fixed. That is RS and RL. only input voltage is changing. The output voltage remains the same as long as the input voltage is maintained above a minimum value. So the percentage regulation of this line regulation can be calculated as del VO by del VI input into 100, where VO is output voltage and Vin is input voltage, whereas del is nothing but changing. It represents changing output voltage, changing input voltage. So del VO is the change in output voltage for a particular change in input voltage, that is del Vin. Let us see load regulation. In this type of regulation, input voltage is fixed and the load resistance is varying. The output volt remains same as long as the load resistance is maintained above the minimum value, and the percentage of regulation can be drawn as VNL minus VFL upon VNL into 100, whereas VNL is the null load resistor voltage and VFL is the full load resistor voltage. With this, I stop here. Thank you.